Okay, we're done.
Right.
Thank you very much.
Holidays.
Yay!
Hey.
Hello and welcome. My name is Richard Simon. I am Cloud Therapist. This is the June episode of Cloud State of Play. Well, it's a lovely time over here in the UK. Summer's here. We're hitting temperatures of around 26, 27, maybe even 28 Celsius at the moment. And that seems to be the forecast going forward right now. Just off cam, you may see I actually have my portable USB fan. Yes, it's that warm here for us. And to kind of get us through all the heat that's generated by IT equipment and technology, I have the Paul Bevan joining me again. Paul is the Director of Infrastructure at Bloor Research. How are you, sir? How's it going?
I'm very well. I haven't been called cool in many years.
Well, I was kind of playing around the temperature thing and then kind of juxtapositioning that with you being cool.
I'll take it whichever way it's meant. Yeah.
I'll take any compliments I can get at this age. Yeah, I agree. It was quite funny. Anecdotally, I was on the tube. That's the London Underground train, by the way, for those who are outside of the UK. I was on the tube the other day, and I just got on a station on the I can't remember which line it was, but I'd just gone on this train, and this young lady immediately sprung up from her seat and offered me her seat.
Hey.
Am I really that old? Do I really look that old? Oh my God, that was funny. That was funny.
It is a defining moment when that happens to you for the first time.
It happened. That was the first time it happened.
It's happened to me. Yeah.
Yes, I declined, but it was very, very kind of her to do that. So if you're watching this, whoever you were, thank you very much for that reminder. Anyway, okay, so we have 3 more topics here for you in June, and they're absolute crackers. You guys are going to love these ones. Okay, so the first one that we have, I think, Paul and I have been sparring over this for some time. We started, I think, the conversation in March or April of this year. But anyway, let's tell you what they are. So first one, what level of uptime do your business services require? So that's kind of the first thing that we're going to explore for today. We're going to talk a lot about availability. We're going to talk about disaster recovery and various other things. So that's the first one. Second one, Dynatrace put something out recently called How Modern Cloud Observability Tames Complexity. So that's an interesting one. Like, we're kind of talking about cloud observability, and I think they sprinkle in some AI into that conversation. I think that was a presentation or something that they put out as part of a paper. So we're going to look into that Dynatrace report. And the third one, which is actually quite prominent at the moment, is another report from McKinsey. Well, actually, it wasn't a report. This was actually a webinar that they held. And it's called GenAI, Data Centers, and the Energy Equation. So what leaders should know. So this was actually a webinar they did recently. Paul and I watched that, and we're going to go through that and give you our opinions as well. Okay, so let's get going, Paul. First one, our first topic, what level of uptime do your business services require? Now, as I said, this was based on an email exchange that you and I had back in, towards the end of April, I think. But it was originally also based on, I think, an article that came up, which was really more about sort of the securing your GenAI workloads, right? So securing your LLMs and whatever you're doing in GenAI by Aquasec or Aqua, as I like to be called. So Aqua actually put something out as a post on LinkedIn. I'll drop the link for that in the description of the video, so do check that out. And then we kind of started the conversation around I think their premise was that GenAI models kind of exponentially increase the attack surface on your environment. And then we talked about, you and I kind of drifted into uptime, downtime, disaster recovery, and things like that. So we kind of shifted a little bit away from the AquaSec original post, which is around genai, but we focused a lot more on the uptime. That was the conversation. So that's kind of really the area that I think we wanted to focus on. So I had a number of views around that, but you kind of give me what your thoughts were in the exchange that we had.
Well, the term uptime itself is not always very helpful.
Precarious.
And it's too broad in the sense of it tends to be used for data centers. And you hear about 99.999 availability, uptime availability, and that's only I think it's about 26 minutes of downtime a year, but that's at a data center level. You think that's not useful if you're talking about individual applications. And we got talking then around, the criticality of those applications. And so it started with we started to look at it from the point of view of, well, you need to define the category of your applications, which are really critical to you that you can't afford to lose. And so we got into that sort of debate and looking at all the sort of mean time between failure and mean time between to resolve or to respond and all those sort of things to say what's important to you. I think at one point you said there are certain things that you can't affect. I think you used the term nuclear war. And it's it doesn't matter how good your systems are, you're not going to recover from that. So it became very much what are the sort of critical measures that you need to look at to ensure that your systems are going to work as effectively as possible. So it's almost like incident management. What was the incident management approach? But being able then to understand the impact on the business. And so it's that sort of twofold. And then how do you mitigate that? And we can talk about, what happens if it's a system you absolutely need, you can't live without.
Yes.
Or is it one where you can actually, days or even weeks without it being a critical problem for the business?
Yeah, so absolutely. So we'll kind of circle back to I think that, but the initial I think conversation was we were talking about or I mentioned the fact that and again going back just to what AquaSec was saying in their post, we said about my point was that not everybody is going to want to do their own training and inference kind of on their Gen AI. So a lot of them will kind of end up in AI SaaS. And then and I think that was the trigger where we said, and I said that will depend on the SLA that you have, with the vendor. And I think you kind of flippantly dropped me a reply was, but all depends on your, SaaS provider or something like that. And then we kind of went into, things like the SLA and sort of how you measure that and things like that. So there's definitely an agreement. We definitely agree on the point that there is no system that's
infallible
and guarantees you no downtime whatsoever. I think that's impossible, and exactly that's kind of what we because of what we were sort of talking about. But as we said, you're right, and that there is ways to get around that, right? And then we have to look at those, first of all, those kind of risks, weigh up the risks, and then see what we can try and work on to try and actually prevent. Which are the preventable ones, and which ones we can't do anything about. As we said, like a sort of a thermonuclear war or something like that, we can't really do much about that. So that's not the sort of scenario that we can look at. So I broke it down. I don't know if you recall from the message. I broke it down into sort of the possibles and the impossibles, and kind of really being the looking at the differences in those and what are the scenarios of the feasibility of those. So the possibles, I think, were more around, yes, we know these are possible, these are going to potentially happen, and there's potentially something that we can still do something about them, but their event is still out of our hands. So there's activities that may happen that are outside of our hands. We can try and prevent them, and they are possible, but they're kind of still out of our hands. And then these sort of the impossibles I think we were looking at was there's nothing we can do about it, and trying to and we can't prevent them either. There's no way to actually prevent them. There's nothing that we can put around them to actually make them or mitigate them in any particular way.
So from my perspective, it was a little sort of top heavy in the sense that the impossibles are the thermonuclear war, or attack of the zombies, and all your IT ops people, every IT ops person out there is now turned into a zombie who can't do anything. The crazy
the zombie apocalypse.
Most of the things you were talking about come into the possible category, the possibilities category. But so you have to get a bit more granular, I think, and so I'm trying to talk about specific applications. If you're a city trading operation that's going to lose millions, if not billions of dollars every minute because they can't trade, you effectively need mirrored remote systems, and therefore the application's got to be designed so that a proper OLTP, so that you mirror it completely and you can flip over to the mirror without any loss. I've seen it done. I've seen it done in a mainframe environment. You're the sort of the expert in sort of newer systems. So I would say, have you seen that in newer systems where you literally mirror every transaction across to another site?
And talking of those sort of impossible scenarios, so we kind of mentioned nuclear war and the zombie apocalypse, but also I think more recently we've heard from things like on the continent in Europe, actually, and kind of the EU, the European, the sort of European Union and the European Commission is more concerned about, the US kind of turning off public cloud on the continent. Now, I think, I would really class, maybe not as bad as a nuclear war, but certainly in that sort of improbable scenario, and again, impossible to. If it were to ever happen, again, impossible to be able to really handle that. Now, you could also look at kind of the likelihood of something like that. It's a possible, improbable, whatever. But you could also look at the actual event itself and see what's the feasibility of that. What is the actual feasibility of that? So again, I'm putting that sort of the US decided to turn off the access to public clouds in that category, because that will be not just catastrophic for, of course, us maybe in Europe, or at least the continent. They may not do it to the UK. We are supposed to be, after all, close partners of the US and that special relationship that we have, but it will be disastrous economically to the US economy as well, let alone the globe. All over. So for those reasons, I think all this kind of running around, panicking that the US is going to switch off the public cloud in Europe, I think is completely uncalled for. It's the sort of panic that we don't need, and that's the sort of thing that we can put out in that same category as the zombie apocalypse and nuclear war. Maybe not as flippantly, but certainly in terms of likelihood. So what I would want to look at, and this is instead of that, this is actually quite a legitimate pursuit, is the cloud abstraction type of activity. So it's not a DR but it's a risk mitigation. You're just really taking back, with cloud abstraction, the idea is that you take back some of those services that you would normally rely on a public cloud provider to give you, whether it's observability or DevOps or automation or something like that. So cloud abstraction would certainly be a
Are you saying
legitimate
you
thing
bring
to
them
look
back
at.
to a private cloud?
No. It depends on how. I mean, it's entirely up to you how you want to do that. Whether it's a managed service or you run them from the privacy of your own data center, or you use a SaaS solution instead, a third-party SaaS solution that gives you a different perspective on that. Now, I know that some of those also run in public cloud, so you kind of back to square one. But the idea is that if you're in that area of business or the market, or you're regulated or something like that, then there's obviously different ways of abstracting. There's different ways to actually do that. That not only gives you independence from the hyperscaler, from the public cloud provider, but it also gives you the ability to do multi-cloud as well. So you can imagine a scenario where your automation, things like infrastructure as code, your observability, your DevOps, and your GitOps is all done through a third-party solution, not a solution that's actually sitting in a hyperscaler.
Yeah. Just listening to that, you still get the sense that abstraction you're talking about and the sort of mitigations you're putting in place are still very much in the sort of, well, we need a few days to get it all sorted out in the event that the worst happens. Mm-hmm. So again, it's back to what's the impact on the business? Would they be able to handle that?
Oh, yeah, absolutely. Yeah. So you're back to, so we're kind of trying to really define what are the rules of engagement, if you like. And then once you're kind of defined those, then you can actually go and, what you said earlier, going back to your point of circling back to about, okay, so what are your kind of worry levels on these services, on these business services, which are the ones that your business can't live without? And as you said earlier, which ones are, well, we'll get them fixed when we can. There's no kind of business criticality, based on those particular services.
I think I'm not sure it's a difference whether we're just looking at it from a slightly different lens. I would say you start with the first one, with the, how important is this application to you if you lose it, and go from there, and how likely is it to fail, all those sort of things, so that the IT ops teams can then configure, if you like, their architecture and where they put their systems, where they put the applications, based on the business risk that the company has put together. Otherwise, you're saying, I think you're putting the cart before the horse if you don't do it that way around.
You could do it. I mean, the only issue is that you could spend all that time assessing, all those things, and then you find that actually you're not able to deal with them, or the cost of trying to deal with a failure on something as as important as a transactional a platform for a bank or a trading company is almost cost prohibitive in terms of what you want to do.
But again, that's part of the initial risk assessment. When you're looking at risk, you're saying, what's the financial or business risk to me, and how much is that going to cost? So it's, if you're a financial trader and you're going to lose millions every minute because you're missing the trades, then the fact that you then have to spend 10 or 15 million pounds replicating the system somewhere else is probably neither here nor there. But the other part, of course, is how often is that likely to happen? So again, you've still got to look at it in the terms of how, yes, it's a horrendous risk, but it's only going to happen once every 30 years, or once every 20 years, or whatever that time frame is. What do we do in that sort of scenario? Can we live it? So all those things come to play. So you're looking at it from a proper risk management perspective that says, here's the impact. here's the likelihood of it's happening, and here's the mitigations. Do the mitigations outweigh the cost of the mitigation outweigh the benefits of keeping it up all the time? You'd have to run all those first to then say to people, right, now go do this, this, and this. Otherwise, I think I say, I think it's cart before the horse if you don't do it that way around.
You can, yeah. I mean, I'm not saying that you can't, but I think these are two distinct things. One is, looking at the like I said, the impossibles, the situations where we can't prevent them from happening, and we shouldn't be really looking at catering for those and mitigating them, versus the ones that we are still going to happen, so out of our hands, but we can mitigate around those. So I think that's a separate distinction. That's a separate feasibility. That's a separate study to do to see what those are, and then say, okay, so now let's turn to, as you said, our business applications, our services, and see which ones we actually really need and our business really needs in order for them to, in order for our business to continue, to have that sort of, continuation. Yeah. And I think those are two separate exercises that you can do. And yeah, I mean, I guess you always start with an assessment. Even when we migrate applications into the cloud, we talk about assessments and assessing applications, assessing workloads. So that will, I think, always be there. But I think that's kind of a separate exercise from actually saying, well, let's look at how we're going to try and prevent these things. What are things we should be looking at preventing? So a region goes down, in a public cloud, we should be able to, to deal with that. Or our Kubernetes cluster fails, there should be a recovery capability, that sort of thing. So those are fine. Those are sorts of things we can do. But as we said, zombie apocalypse, I don't know, alien invasion, whatever, those things we can't really do much about. Yeah. So I think that's kind of the distinction that I'm trying to highlight.
I think it's contextual. I think it'll come up in the Dynatrace in the second piece that we're going to talk about. It is contextual, because if you say, you talked about Kubernetes, is every system you've got reliant on Kubernetes? And how is it reliant on Kubernetes? And it won't be, because your systems will be so diverse that you won't just be reliant on Kubernetes. So you'll find unless you've got the context that says what applications are impacted by Kubernetes failure oh, it's these applications. Well, that's not a problem for application A, but application B, oh my goodness, if Kubernetes, falls over for some reason there, and that impacts application B, we're in trouble. So again, that's why I say I think the cart before the horse. You do, what are the applications, the business applications that we can't live without, and grade them, and say then you can start looking at well, how often is the failure likely to happen, and what's the cost of mitigation? All those. I think that's all I was saying.
Yeah. No, I understand that. I think maybe as you said, maybe we're approaching it from different directions. You're kind of on the, per business service, and I'm kind of looking at the type of things that you can do to
if I was the chief exec and you came to me and said, I need to spend all this money on providing mitigations against Kubernetes failures, his likely response is, what impact does that have on my business?
I think the likely answer is, what the hell is Kubernetes?
What the hell is Kubernetes? Yes, exactly.
And how do you spell that?
I nearly used a much more inappropriate term.
Yes. Yes. Okay, Paul. You can swear. I'll get done in the editing. We'll get done all the post-production.
Yeah. To me, it's the whole of the issue around availability, resilience, and recovery is the importance of it to the business. And therefore, you start with what are the things that if it closes down, the business is out of business very, very rapidly, and you just it goes from there. Then you'll get a situation that says, oh God, I've got 65 different applications that are mission critical that all rely on Kubernetes.
Yeah. So
Okay, we need to do something about Kubernetes, mitigating potential outages caused by Kubernetes.
okay. So what are some of these types of events? So there's kind of things like accidents. So the AWS Fat Fingers event or whatever, from some years ago, and an airplane engine's kind of falling on our data center. It's nothing we can do. Those are kind of just accidents that happen. There's also obviously things like deliberate, so like sabotage, cyber attacks, things like that.
I will correct you about the airline
Oh,
engine
go on then.
falling on a data center. Lloyds Bank had a data center just south of the Thames near London Bridge Station.
Mm-hmm.
Not there anymore. It was designed and constructed to take the impact of an airliner coming down on it because it was on the flight path into Heathrow.
Mm-hmm. Yeah.
It was one of their main, they had two main data centers, one in the city of London and one up in Peterborough. So they could mirroring and all those sort of things. And they literally designed the data center so that it would withstand an airliner hitting it.
Okay.
That was long before 9/11 as well.
Yeah. Do you know who was managing the data center?
They were. It was, and this is back in the 80s.
Oh, okay. Right.
So they were managing their own.
Okay. Right. Okay. Yeah. So kind of, accidents obviously will happen. So there's kind of, as I said, in that sort of, impossible sort of category. Deliberate sort of sabotage, as we said, or cyber attacks, again, will happen. Again, impossible, but we can potentially, cater for those. And then, unforeseen or sort of unpreventable, as we said, those, impossible situations as well. So those are kind of maybe the three. I couldn't really think of any other ways that things would happen. But those were the kind of, the ways that we could do that. So the question is, as we said, how willing are you to lose certain types of business services, as we said, kind of what is mission critical to you and so on. That's where we sort of start getting into things like MTTR, MTBF, and MTTR, and all those sorts of lovely four-letter acronyms, which have kind of been a little bit superseded recently because you kind of got things like SLAs, SLOs, and SLIs as well. But I do love all of that. I do love kind of talking about all of those. I think those are really interesting.
You provided the link to the Atlassian report.
Yes.
And
the Incident Management Handbook. We'll drop a link for you in the description.
And I had one major issue with it, which is that we talk about mean time too. And they then describe these always as straight averages. And actually mean time, if you know and I'm not a good mathematician. In fact, I just about got my my O level in maths, never mind A level, didn't go anywhere near it.
I saw you reaching for your A level there, Paul. That was kind of wishful thinking.
That was wishful thinking. There was no way, my brain is not mathematically oriented. Yeah. But meantime, average is just a straight average. So if you get one downtime of, 100 hours and 10 downtimes of an hour, your average is, 110 divided by 10. Yeah. And it gives you a completely wrong impression of what's going on. So the mean takes, if you like, a weighted average, so you get a much better picture of most downtime is only right down at that end, not the one that took 2 days or 3 days to resolve. They were all 20-minute ones. So that was my only argument. So if anybody watches, it looks at that, just be aware that the way they do it with just a straight average can give you some very misleading indicators as to the likely what you're looking at in the likely downtime.
Yeah, I think that was maybe kind of need to clarify that a little bit. But yeah, there's obviously lots of stuff here. There's things like MTBFs. That's kind of between mean time between failure. There's mean time to recovery or repair. There's things like mean time to failure, mean time to acknowledgement. And then you get into the SLA stuff, which is service level agreement, which is what we talked about earlier on, about that sort of, AI SaaS provider giving you that as part of a contract. And then you got SLO, which is service level objective. So that's in the context of things like software development, representing specific measurable targets for the service's performance. And then you got SLI, which is service level indicator. So a quantitative measure used to assess the performance of a service. I had to look that one up because I couldn't remember it. But yeah, those are kind of all different ways that we can kind of measure some of these things and the mean times of things actually happening. But I think, as you said, we need to look at the business services. We need to look at kind of how, which ones are the critical ones, identify those. That normally, and I'm not an expert in this area, I presume they do like an assessment of those. You get somebody in who kind of knows what they're talking about when it comes to DR, disaster recovery, and business continuity and things like that.
Yeah, one of the things that I mean, yes, that you will do that assessment with people who understand what will happen to the business. It'll be the various business heads. Will also be looking at the financial people to say, is this right? If we don't do this, is that the hit? I mean, look at Marks and Spencer's now and the problem they've had with the cyber attack. And the outages that they've had in terms of, empty shelves are very, very visible. And they're talking about a £350 million hit to their systems. Yeah. Now they've got to go back and think to themselves, in the light of that, how critical were those systems to us? We reckon we're going to lose 350 million. We don't quite know what our hit to our reputation will be yet. What do we need to do? Can we spend a level of money to make sure that that thing doesn't happen again? Or if it does, we know how to recover from it very, very quickly.
Yeah. Hey, if you are enjoying the content, please don't forget to subscribe to the channel. That would really help me out. Thank you. Second topic. We were looking at, and I shared this with you, the Dynatrace report and presentation, which was talking about how modern cloud observability tames complexity. So I have to say, I didn't really find this very well. It was quite unremarkable in terms of the kind of the content. Yes, there were some interesting stats in there which I picked up on, and some good highlights. So I will go through those in a minute. But the document was kind of exploring how modern cloud observability confronts the increasing complexity of IT environments that are being faced by enterprises as they shift to cloud native architectures. So that was an interesting point, and that it wasn't kind of just you're doing observability and you can use these tools, but it was actually during that sort of shift for enterprises. What was your view of this, Paul? Just kind of
a bit like you. I mean, it's a fairly unremarkable. I mean, Dynatrace are one of the leading. In the old days, you'd have called them monitoring platforms.
Yeah.
Nowadays, you call them observability platforms. So we can come back to that. And they are one of the leaders. I did a report on those sort of platforms pre-COVID, about 2018, I think I did a report, and Dynatrace scored very, very highly based on the criteria that we put together. So they're fine. They're a good company to look at in terms of that sort of report. But it struck me as odd. It was an ebook, and you're thinking, who were they actually aiming this at? Because the IT operations teams have known this for some time. Yeah. And even, the CIO will have known this for some time. And you think, who's still arguing about that? I mean, I haven't really focused on these group of companies in the last 3 years or so, simply because they all say roughly the same thing. And actually the issues haven't really changed. Yeah. So it was really strange to see this one come out at this point and thinking, who actually are they talking to? They can't, are there still people out there who don't understand this? Maybe, but,
And they did go back as far as saying, what is observability in the early chapters as well, which was, I mean, I'd give that a paragraph in a subsection somewhere, but you don't have to kind of dwell on it.
Yeah, we've actually, the observability suffered the same sort of fate as many of the sort of classifications out there, including cloud, that it goes through a sort of period, something very specific, and it becomes something very general as you go
Yes.
along. And observability's got that. I'm sure there are people who are DevOps practitioners and sort of platform engineering practitioners who will be pulling their hair out if they've got any left, the fact that a company like Dynatrace is using the term observability on what is
Yeah.
effectively a monitoring platform.
Yeah. Yeah. And we discussed the convergence of things like observability, AIOps, APM, and so on a long time ago in Class City Play. I will try and dig this up for you guys. We had been through all of this kind of where you had, very specific players, the likes of Dynatrace were in this sort of the observability space, the same as Datadog and New Relic and a few others. And then you had people who were kind of in the application performance monitoring, so App Dynamics, Turbonomic, and a number of others. And then you had AIOps, so it had MoogSoft and people like that who were kind of playing in that field. And then I think all of the players in all of these categories, almost all of at the same time realized they could be in each other's categories.
Yes.
And started renaming their marketing into, oh, we do AIOps as well. Oh, we do APM as well. So everybody's now, as you said, it's a homogeneous kind of, mixture of all of these things together. And it's quite a blurred sort of effect. There has been other effects that have come along in that observability space that have kind of impacted it, but we're not going to focus on those here today. But you're right in terms of kind of all of them pretty much now doing the same thing for the last 2 or 3 years.
Yeah, the one area that, and I've written about this quite recently, is people talk about full stack observability, and I think in the report, which we'll provide a link to. I think I ended my executive summary piece by saying, be advised, claims of full stack monitoring and visibility into public cloud environments do not usually cover the gap. And the gap is the public cloud networks. And I'll come back to that, and therefore, there's a whole load of claims being made about end-to-end visibility.
Yeah.
They are very quiet about how they monitor when it disappears into the public cloud network, or even the internet service provider network, because they're software defined, and very virtualized, software defined, very ephemeral changes. Old IP network address monitoring doesn't work in that environment. All those sort of issues that says we need to find a different way of doing that. And there are allusions in most of the vendors' marketing to the fact that they gave end-to-end visibility, and I think the vast majority of them would struggle to live up to that.
Yes, indeed. And you and I have talked about this before. The kind of the what I class as a sort of a cloud network management category, and we talked about our favorite companies in that space.
Yeah. So, but it was. I could have written and read that same report 5 years ago.
Yeah, indeed. Okay, so let's just kind of dive into the report a little bit more. So they did mention some interesting stuff. So things like IT environments generated 79 zettabytes of data worldwide in 2021. I suspect now with the advent of genai, that's probably doubled, if not tripled by now.
Yeah.
So again, observability focuses on the usual, what I call the MELT parameters. So your metrics, events, logs, and traces. Paul corrected me a while back, said actually MELT is a thing. It's actually an industry thing that people talk about, which I had no idea it was. But I just came up with the idea because I couldn't remember metrics, events, logs, and traces. And actually, events is not something that I came up with. Somebody else reminded me of this. Why don't you include events in your acronym? And I thought, oh yeah, actually that's a good idea. But then Paul kind of deflated me a little bit by saying,
sorry about that.
It already exists, Richard. It's already there. People do use MELT and observability. And I was like, oh, thanks, Paul. Burst my bubble. But anyway, so the other bit that I picked up on, Dynatrace said there are 3 areas for, or three kind of things where when you look at data. So volume, velocity, and variety. But I beg to differ. Having come from IBM, there's actually 4 of them. Do you know what the 4th one is, Paul?
No, go on.
Veracity.
Ah.
So you have volume, you have velocity, variety, and veracity. So that's accuracy of the actual data that you're getting, whether it's crap or makes sense or whatever. So Dynatrace, sorry guys, you need to go and just Dynatrace, just type in IBM Big Data 4Vs into Google. You'll get it, or even ask ChatGPT. It'll be the first link that you'll get on that. Believe me. So yeah, 4 Vs, not 3 Vs. That I exist. So I had to nitpick that one, unfortunately.
And probably they've missed out the most important one, because if your data is crap in the first place,
yeah.
then any AI is going to struggle to give you a decent prediction about what's happening.
Exactly. And yes, and this is supposed to be AIOps, right? That's kind of that's what the that's what observability includes these days, or should include. But we'll come back to the AIOps because I have another bone to pick on that one. So also another interest is I started to really realize that chapter 3 onwards from the ebook was kind of the most important pieces. So another bit that I picked up on was said teams need to embrace all data types. Well, no, actually teams don't need to embrace all the data types. The tools need to embrace all the data types. The whole point is that the teams don't have to go through logs and events and blah 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 and all that kind of nonsense, all the melt nonsense. It's the tools that have to do that, and have to do that in a clever way enough so that they come back with information that actually makes sense, that's relevant, and gives at least a way to remedy any issues as well, if not prevent them altogether.
Yeah, I think they would, to an extent, they got mixed up a little bit in terms of the siloed approaches of teams.
Yeah,
and brought them into this one. And I think there was a sort of element of trying to say you need to work across the silos because you're going to get data from all over But I agree with you. Then it's the tools need to be able to ingest the data and do something with the data without any input from the operations team.
Yeah, and I mean the ops guys have embraced it. They do, they acknowledge this, right? The SREs and our cloud ops folks and IT support folks, they have embraced it. It's the tools that need to do that.
Yeah.
But I would also like to see if we can maybe indulge me for a minute. If I can add on to my melt, and I will call it my melt acronym. I don't care. I came up with it and I didn't even know it existed. So that's kind of my claim to fame.
You're not bitter about this, are you?
No, not at all. But if we can maybe extend the melt to include remediation or remedy, how do you actually fix this problem that's come up? And also prevention, how do we actually prevent it from happening? So not a melt, but a kind of a melt rep, R and a lowercase e and a V. So when that makes sense. You guys tell me what you think. But anyway.
Yeah, I mean, I was getting to the point of saying prevent it happening. Prevent what happening? Bad data? Or prevent the incident from happening?
It's the incident, yeah.
Oh, yeah, okay.
The focus for me would be the incident. So things like, you've had, so my AIOps, my observability platform, which includes AIOps, has picked up this problem. This happened last Saturday at 3 a.m. and it kind of woke you up as a SRE to go and fix it or whatever. But I've automatically now remedied this. And in order for you to stop this from happening again, here's the options. Here's what you can do. Okay. And it gives you the prevention as well.
Yeah. Right? So I think we're at a stage now where you can take that a stage further, which is because you're collecting so much data from so many different sources, you can start to see at a very granular level where parts of this is where context comes in. So you need the context of what application is using what parts of the system, right the way through, end to end.
Mm.
And if you start to see a problem in a particular switch or a particular server or a particular data environment, before you can start to pick it up before it impacts the end user. And this is where some of it's got quite clever now in saying, because they've got the context right, they're going, oh my goodness me, we seem to be slowing traffic through that particular switch.
Mm.
And that's going to impact that, and that, and that. And it's almost before it gets to be a major, certainly before it gets to be an outage. But as it starts to slow down, to actually say, no, hold on, that's now going to cause that application a problem.
Yeah.
Let's reroute, different switch, whatever, and so there's a lot more of that capability going on now within the sort of AI part of the AIOps. I mean, and again, this is not LLM stuff. This is, pattern matching, pattern recognition, machine learning type stuff that's been around for a while.
Yeah.
I think Big Panda were the first ones to look at an LLM and say, right, how do I use that as part of the sort of predictive piece? And that's coming in, but it's been around for a while. But again, it's the lack of context. If you do it in silos and you can't see the whole path of the application, then you provide the context to the AI to say, hold on a minute, if that switch is now causing a problem, this particular application is eventually going to come to a grinding halt. Get in there quick.
Yeah, exactly. So, okay, so let's look at some of the, let me kind of just highlight some of the, give you the highlights of what I kind of picked up on a little bit. And some of these were unfortunately howlers, so we're gonna have to call them out. So it said modern cloud observability tackles the complexity, as we said. So they're talking about things like multi-cloud, microservices, and containers, and that's fine. I mean, those are, yes, the latest architectures, and we do need to wrap them around some sort of, monitoring and, with observability. AI and automation transform observability. And we'll come back to that because, again, you mentioned something about Big Panda, is it that you mentioned just now? Yeah. So we'll come back to that because I think I've got a sort of bone to pick, around that. And then it actually again mentioned 3 pillars for observability. So logs, metrics, and traces, but forgot about events. So again, that's not the full melt, right? For actionable insights. Talked about digital transformation amplifying cloud complexity. Yes, that's quite valid. I think we'll agree with that. Teams evolving from legacy monitoring tools that are old sort of data center systems management tools. Again, I agree with that, to kind of more of a AI-powered observability platforms, as it's called them. Of course, Dynatrace's platform automates data collection. Well, yes, it is an observability platform after all, so quite academic. It does RCA, root cause analysis, and cross-team collab and things like that on a cloud scale. Sure. And then real world case study highlights how observability supports essential government services during crisis. Okay. Not sure why that one got picked out specifically, but there you go. So in those highlights, Paul, I didn't really see anything like startlingly new.
Yeah, no, I agree. There was nothing startlingly new in there at all. The one that intrigued me was, again, right back down on the sort of use cases, was when they came to understanding and getting a grip on the business service metrics. The only 3, so all the other use cases looked to be US based, and suddenly you got 3 British ones. It was, I was just trying to find where they were. They're right down the end. Oh yeah, here we are. Yes, you had, they came up with operate more efficiently, 60% greater operational efficiency on SAP, fewer tickets. Those are not really benefits, they're sort of features, I think.
Yeah. Would be, yeah.
But they were, SAP on one, it was Kroger on the other, Porsche Informatic on the third one, which was faster issue resolution. That's okay. It's good. But when it came drive better business outcomes consistently was one where they were talking. They had three. Higher cart value was Mitchell and Butlers. So that's a
Okay.
brewer,
Hmm.
beer company. Lower customer churn. So Vitality, which is the sort of health and
The health company, yeah.
leisure
Yeah.
company, and then increasing conversations, BT from um, so again it was I didn't know whether that was down to the fact that there's been more focus in the UK
Mm.
on those business outcomes than it has in some of the other places that Dynatrace do business. I'd love to ask them the question, why did you end up with three British ones in there? And no, you would expect to spread it a bit. And of course they weren't. There was three quite specifically British ones,
Yeah.
which, as a Brit, you're very pleased about. But you actually compared to the others that have, they're either American or German or Kroger's South African, isn't it?
Sounds like that. I don't know.
But anyway, I mean, so that was just a sort of intriguing one that yeah, they have gone to the point of looking at what are those better business outcomes.
Yeah. Yeah.
But just a point, it's just a point to make.
Okay, so I picked up on some key insights. So let me read you through this. Now, there's a lot more of this stuff in either the description of the video, if YouTube allows me to put it, or a pinned comment in the comments section, guys. So have a look at that. I'll try and put a lot more of this stuff in there. I try to do that all the time, so hopefully you guys find that useful. But key insights that we picked up on: cloud complexity wall requires new observability paradigms. Sure, yeah, I don't think that's anything different. Cross-team collaboration hinges on a unified observability solution or platform. Yes, I mean, there's a lot more to it than that, but because you could also say, well, they all need Slack or something, right? Or Teams to talk to each other. That's equally important. Context and user data beyond the 4 pillars enhance insight quality. So yes, I guess, and I could say something like metrics, logs, and traces form the core observability pillars, but they are insufficient alone in a multi-cloud environment. I guess so, because you need to kind of go beyond that, because you need to look at, as we said, networking, cloud network management, is one of those, data and storage, data observability. See, this is the thing. I don't know if the likes of Dynatrace and Datadog, I'm just kind of breaking off the insights here for a minute, but this is relational, is whether they'll go and buy one of those data observability companies and say, we need to add data observability to our Dynatrace platform or Datadog platform or whatever. So that would be an interesting one.
Yeah, I mean, data observability or even data handling, data cleansing. I mean, because we talked about getting quality data in there.
Yeah.
And there are some very specific veracity, and there are some very specific tools that do that. And you think, yeah, they could go and buy that. At the moment, people are still using separate tools for those. And I think it's always the challenge, that there's a limit to what a platform will do. And, the more they try and sort of add bits to it, it can get slightly clunky unless they're careful.
Yeah. Okay. So let me finish these key points as well. So where else? So we talked about the context and the data. The other insight that I picked up is said a platform approach is essential for scale and complexity, and I do agree with that, because I mean, obviously you kind of need that if you're going to cater for things like multi-cloud architectures and things like that. Observability is crucial to digital transformation success, definitely, because you're now entering into things like the age of DevOps, and you're kind of going agile and sort of picking up things like platform engineering and so on. So definitely, observability is required for those. And then I think it mentioned the government case study again, which was interesting. So so those were kind of the insights. But the point I wanted to make, and we've kind of mentioned this a few times. You mentioned Big Panda. AIOps, the AIOps aspect of these observability platforms. So there's MuleSoft or Dynatrace, like I said, they all kind of say the same thing. Is the AIOps aspect now, and you may have answered it for Big Panda, but is that now Gen AI, or is it what I would call dumb AI, the old traditional sort of AI, or has it now evolved to include Gen AI?
It is evolving to include Gen AI. I think Big Panda was first in, but an awful lot are still doing machine learning.
Right. Okay.
Pattern matching, pattern recognition, a little bit of predictive analytics, but not
lots of if and then statements.
Yes. Yeah, not. So I think
just being facetious then.
Yeah, but they've almost got to come out and say we're using Gen AI to do X, Y, Z.
Yeah. Okay. So that's definitely important. I wish there's like a chart that tells you where they are. And, Gartner, if you're listening, IDC, it's a good piece of research for you guys to pick up on, because it'll be really cool to see where they are in that and what sort of features, they've already implemented and are, kind of on the roadmap. Okay, so that's one thing, and then the other thing I kind of wanted to pick up on it, and like I said, I kind of mentioned it earlier when I extended the MELT sort of acronym, is why just stop at observability? Why not take more of the actions, do the things that the likes of MuleSoft were saying that we're doing with AIOps and so on, if a number of years, of six years ago now, right? Why are they stopping at just saying, oh look, your Kubernetes clusters failed, oh look, this service is not performing up to the SLA or something? Why not actually go beyond that and do the remediation and the prevention as well?
Yeah, I don't know whether they've. Let's put it the other way around. If you look at ServiceNow, ServiceNow are in that sort of remediation phase, and actually they're coming back the other way in terms of moving into what we would call AIOps.
Yeah, they would. That's natural, I think.
So it's natural for them. Whereas I don't think in many cases, because they've still got deep down, they're a monitoring company.
Yeah.
Deep down, they're monitoring. All of them. You get, as I say, because MuleSoft moved out. I can't think where they sort of moved into, but they got bought. I can't think who bought them, but they moved away from the AIOps marketplace. It was quite strange. So you don't really see MuleSoft, pushing hard in there. Some new companies are coming along in that space. But none of, and they're talking about automating simple remediations. Big Panda certainly talk about automated remediations of the fairly sort of simple variety, and ensuring that they don't happen again, those sort of things. But everybody seems to have been slightly wary of treading into the sort of service management piece, I think.
Yeah. Well, I don't know. I was just curious about MuleSoft. So I just looked up MuleSoft, and it says MuleSoft is an AIOps company.
Oh, it's still said. All right, okay.
According to this, they're still in the AIOps platform focused on IT incident management and the utilization of machine learning and AI. That doesn't strike me as Gen AI. That just strikes me as dumb AI.
Yeah,
basically, the old AI type of stuff. So
they're not high profile anymore.
Oh, acquired by Dell in 2023.
I knew somebody had bought them, but Yeah. Okay.
See what a quick reference on a cloud search gives you. There you go. So acquired by Dell. And God knows what Dell is using them for. I don't really want to speculate into that.
And it, again, probably accounts for the fact that there hasn't been a lot of product development noise around MoogSoft in the last couple of years.
Yeah, yeah, and we've completely missed that on our annual review. Just straight past, I think, in 2023. Okay, yeah, so that's kind of really the main things for me. It was there's a lot of kind of academic stuff in the report. They got all their R's and V's and whatever wrong. I think they missed out on that, which was disappointing. The it sounds like the AIOps piece or anything AI related is still dumb AI. Still lots of if and then statements, as the meme goes, not Gen AI. And then, like I said, my thing is can we extend the melt to melt rep? So have a remediation, RE, uppercase R, lowercase e, and a prevention, P for prevention as well. That would be really good. Hey, if you are enjoying the content, please don't forget to subscribe to the channel. That would really help me out. Thank you. Third one, McKinsey webinar on GenAI, data centers, and the energy equation. What leaders should know. Now, this was touted as, I'm not going to read the full blurb, but it said, amid the AI boom, compute power is emerging as one of this decade's most critical resources, influencing the pace at which AI is deployed in our daily lives. Data centers across the globe train the foundation models and machine learning applications that underpin all AI technology. The hardware, processors, memory storage, and energy needed to operate these data centers are known collectively as compute power, and there is a seemingly unquenchable need for more. I'll stop there. What was your view of the thing? And you may mention when they started into the live stream. Paul.
Yes, it was. Yes, Richard very very graciously sent me a link to the this sort of presentation, which was sort of mooted for I think about 50 minutes.
Yes.
I thought, oh my goodness me,
Well, went on that long.
Went on that long, but it was about 12 or 13 minutes in before they got beyond the sort of preambles and actually introduced the speakers and started off. I had to keep pushing the little bar at the bottom to the right to find out when we got to the presentations.
And unfortunately on LinkedIn, there's no preview. So unlike YouTube, where you can pick it up and it kind of shows you, the frames as you're going on LinkedIn, you have to. Because I thought, okay, 2 minutes in. Oh no, still the greeting music. 3 minutes in, no. 5 minutes in, 10 minutes in, still not. Like what?
About 13 minutes, I think. So, and then they didn't leave enough time for their Q&A at the end, which was again amusing, it must have been annoying for everybody who was on the live version.
Yes,
of it. They got, I think, 2 questions in at the end.
Yes, I think they managed about 2. But I mean, the lady who was organizing it, Lucia Rahili, I think she's the global editorial director.
Yeah.
So she had 2 other guys. She had 2 guys joining her. Pankaj Sachdeva, senior partner, and Jesse Nofsinger, who's just a partner. So she, 10 minutes in, 12 minutes in, they finally got going, and she said, let's get started now. I was like, 10 minutes I've been waiting for. I've been like moving the bar along for this to start. And then they even did like at McKinsey, we pride ourselves in. I was like, just skip the intro video. Just like let's get to the freaking meat of the discussion here. And then they talked about they said, oh yes, they had some tech challenges last time around. I would say, McKinsey, you had some tech challenges on this webinar as well. So, still lots of room for improvement there. But anyway, yes, go on. What was your kind of main points, Paul?
I mean, it was for anybody who didn't know about it.
Mm.
There was some useful statistics. The growth rate of the power requirement. They were talking about. I think they overstated this somewhat. 220 gigawatts by 2030, which is 4 times the capacity of all the data centers that we've built up to now.
Yes.
It was like, really? But
Yeah.
and I've looked at others that are the growth everywhere's got this phenomenal growth, but that theirs seem to be, slightly outlying, I think, in terms of, and even that was the median position because they had a best case and a worst case above and below it.
Yeah. Yeah.
Um,
Yeah. The upside was 300 gigawatts, I think,
yeah, but it was
by
sort of
2030.
by 2030. We'll come back to that because they did talk about some of those implications, but the other was 75% of the growth driven by AI. Yeah,
Yes.
okay. Yeah, fine.
And they talked about an AI economy of about $4 trillion by 2030. So it's around 2 point something now, but
yeah. And I've seen very similar figures from across the piece. So I don't, that seemed to be all right. We can argue those till the cows come home because, how the hell do they work that one out? But anyway.
Yeah. So you're right that they mentioned, I think 70 gigawatts right now. That's the kind of current global use. I think the senior guy mentioned that. But the one that I initially disagree with, which is the kind of the premise of all this, is the conflation again of GenAI workloads with data centers. As we said before, and as I've maintained, that kind of initial point I wanted to pick up on was that the GenAI doesn't really need their data centers or any of the data centers that are being built by these players, whoever these kind of players are around the world. It can run in existing public cloud, so you can actually make use of it in existing public cloud, and there's obviously solutions from all the hyperscalers already that allow you to do that. And the other thing to point just on that concept is, or on that sort of conflation, is that hyperscalers build their own data centers. So my question for them would be, who are you building these data centers for? I don't. I mean, are you building these for customers, enterprises? Because the hyperscalers don't need somebody else to build their data center for them.
I think you misunderstand in the sense that the figures they're showing, and I've got another set of figures which are largely similar from a company called DC Byte, that one of the biggest analytics companies for data center, physical data centers, and those figures are for all data center builds. So whether it's an Azure data center or GCP or AWS, all the figures we're seeing are a combined total of hyperscaler, co-location, and an increasingly small number of enterprise data centers. So most of it is either going to the existing hyperscalers or new cloud providers who are focused on AI, and there's one or two of those. CoreWeave is the big one that you sort of think about, or the co-location companies like Equinix and Digital Realty and CyrusOne and all those ones. That's where the build's happening. Those are the physical builds that are happening.
Okay, so who's building these?
Well, they're the hyperscalers themselves. They're not the ones with the feet on the. They put out contracts for building companies.
Yeah, no, I'm sure they do. It's just the impression I got from McKinsey's webinar was that these were, they were not really saying that specifically. They were not talking about that per se. They were talking about, we need these data centers, and I just got the impression we don't need these data centers, and certainly not to that degree, because and they did admit that after halfway through, the senior guy I think came in again and said, what did he say? Because I actually noted that down. It was it was quite important. He said that he probably the growth, he said, and I quote this, is not going to be in a linear flow. It's going to ebb and flow. So it's not going to be like a linear growth. We're not going to see like a we need it. Oh, okay, we've now got to a point where we're saturated, we don't need any more, and then the growth drops. It's actually going to be we need it. Actually, we don't need it anymore because a lot of people are going, as I said before, AI SaaS. All of a sudden, yes, we do need it again because there's now a new paradigm in the genai, in a new
but even
designers come up and so on.
But
I think it's going to be like that.
But even with the AI SaaS, you still need a data center. Somebody has to have the data center. So it's new capacity that's required. Doesn't matter whether it's run by it's a public cloud provider, whether it's a SaaS provider. There is a physical data center that needs to run that. And at the moment, we are short of capacity for that. I'm not
disagreeing. I'm not disagreeing with that. We do need them. I think depending on, like I said, how you, and this goes back to my question from the article that I wrote last year. How are you going to actually implement AI? Are you going to do it yourself? So are you going to do the training and the inference yourself? Or are you going to go to somebody else who actually has already built a model in your market that's specific to your market sector, and you make use of that as a SaaS solution? Because there's a difference in terms of the capacity that's required for you as an enterprise, or as a hyperscaler, as you see the growth that's required by your customers, to go and say, yeah, actually, we're running out of data center space, so we need another region or whatever that we need to build. So as a hyperscaler, yes, you will do that. But as an enterprise, are we saying that all enterprises are going to want to train their own model and kind of do the training and then the inference? Or are we saying that, like some vendors will offer that as a solution, as a SaaS model, that the normal enterprises can just upload their data into that SaaS model?
Yeah, all of those is the answer, but mostly it will be into either a public cloud, a SaaS provider who is probably sitting in a co-location data center like an Equinix or a Digital Realty data center.
Yeah,
and those are the people who are going to have to build out the most capacity. And if you look at the number of requests for new builds over the course of the next 5 years, there are huge requests for new builds and access to the power on the grid. All those sort of things are happening because of this growth. How many of those are going to be enterprise data centers? Probably a minuscule number. It's all going to happen in colos and or hyperscale data centers.
Yeah, I'm sorry, go on. You got your point.
The one point they did make, and it's quite right, and I've got other figures that back that up, is that as you move from training to inference, the likelihood is that these will be more and more, they call them edge data centers. They're outside the big regional hubs of data centers. In Europe, you've got what they call flat D: Frankfurt, London, Amsterdam, Paris, and Dublin. And a lot of the evidence about where people have already put in requests, because the first thing you have to do almost before you start digging is you have to request from the local electricity grid. You have to get permission.
Oh yeah, absolutely.
And that takes, at the moment, they've actually paused it in the UK. Yeah. You can't put a new application in at the moment. There are certain exceptions, but if you just say, "Oh, I'll need a new data center. I want to build one," you go in a queue. That queue has been paused because and that can be up to 5 years to get onto the up to the top of the list. So, but get back to the edge data centers, then there's quite a lot of evidence, and I can provide a report that shows where the requests for these builds are, and they are outside those traditional areas. In America, in the McKinsey video, they were talking about moving away from, the sort of Virginia type environment where you get there to places like Oklahoma and others where there's
Wisconsin,
power.
I think was mentioned as well.
And the like, where there was power. And you can see that on the map I've got of the European landscape.
Yeah.
Where you're ending up in sort of places like Cordoba and Marseille and Dresden and places that are much, because the inferencing, it needs places where, where they're not short of power anyway, because the flat D places are, up against the wire.
Yeah.
But it's also from a latency perspective. If you're going to inferencing, you need to be closer to the markets you're in, which is what the McKinsey people said, and that's quite true.
Yeah, so I think they said in the training you need more power but less performance, and then in the inferencing you need less power but more performance. I think was the kind of
it was much about it was all to do with latency. So they were talking really about you needed to be nearer the actual source of the data, if you like, or nearer the customers, because actually you were delivering solutions based on the inferencing.
Yeah.
You didn't want that to be so far away that you've got a delay, too large a delay.
Yeah. And things like SMRs can't help because they're decades out. We're not going to be able to get those into like a factory line, as we've said before. And we've discussed this before, where we can't do that. So my point is that I actually, the only bit that I really picked up on was this: it's not going to be a linear sort of growth. There's going to be an ebb and flow, and I do agree with that because of the things that I'm saying. I think my view is that it's not going to be like that, because not everybody's going to want to do that, and that will definitely affect the amount of space and in terms of the data centers and the hyperscales data centers that you actually require, because not everybody's going to want to build their own stuff, and whether you do that in the public cloud or do it yourself on the cloud doesn't really matter.
Richard, I'm sorry to argue with you, but
that's fine.
I'm going to argue with you.
Go ahead.
Because it doesn't, you're not building, even if you're not building your own, or you are building your own, the data center that you do that in, whether you're building your own or just using somebody else's, still has to be built.
No, I'm not disagreeing with that. I'm saying the way that you use it is going to be different, because, like I said, let's say, if you build it on your own, obviously you're going to need all the stuff that that's all GPUs and racks and whatever else. You're going to need your data center. But if you're not going to do that at all, then it's down to somebody else to build that. But then the way that you're using it is not going to necessarily need, because you're just on the inference side of the equation. You're not that vendor does not need to provide as much of the capability, the power, the compute. They don't need to build that amount, because you're not using that aspect of the implementation of GenAI. You're actually only using it for the data that you want to upload into that vendor's SaaS model. So I think because of that, the requirements, I think, for performance are going to be different. Even for that vendor, I think they're going to be different. We'll see. We can agree to disagree on that.
I think we're going to have
that's
to.
My view.
I think there's a fundamental flaw there, which we probably need to come back to. But I think the point that they were making, the point I want to make, and where that might come true, is if you look at Gartner now saying we're now entering the trough of disillusion for Gen AI. And that's because, it's gone to the point where businesses are beginning to say, I'm not sure what the use case is for this. They've slowed down because they can't quite work out how they're going to use it to get business benefit. And we're seeing more and more commentary on that. We'd like to see some real stats, but we're seeing more and more commentary on the fact that the use, and you and I have argued about, well, there's no business cases yet, they've got to, so there's a period of risk in the figures based on how quickly the uptake of real applications that use Gen AI, that use, agentic AI, and all those sort of pieces that are coming along. There's a potential for it to say, oh, hold on a minute. And therefore the projections that we've seen may not come to fruition until a bit later. That's a problem for people like CoreWeave, who are heavily debt oriented. Not so much for the hyperscalers who've got big cash piles.
Yeah. I think you may have misunderstood me in regards to that point. I mean, I've maintained that we do have the use cases. I think the enterprises and the IT sort of press and the research and the pundits and the influencers, as we talked about last month, have jumped the gun on that. They've misunderstood what the enterprises are doing. The enterprises are not, I think, maybe they don't realize all the use cases, but they do understand that there's a potential to make use of it. I think what they're doing is that they're taking their time, because this is a completely different shift for them in terms of how they can operate their business. So they're not getting it or not understanding what the use cases are. They're just taking their time on those use cases. And as I said before, when I attended that Gen AI summit earlier this year, that's exactly what I heard from all the financial companies, all the banks, the investments. They were all there. Every single one was there. And I'll drop you the link so you can actually see who was there, who actually presented. And all of their projects, all of their proof of concepts were 12 to 18 months long. They've been at it since June of last year, right? So that doesn't say to me that they're in a rush to get this out, to put it on the inference side and get it to interact with their customers, especially the banks, let alone somebody else who kind of has a lesser requirement for that. So it's not that there is actually a disillusionment. I think Gartner's wrong. My understanding from what I'm seeing on the shop floor is that there isn't a disillusionment. There's just we'll take our time to get this right. That's not the same thing as people not finding the use cases or being disillusioned by AI. That's what you read in the press. Yes, that's what our favorite influencers, and we all know who those are. We'll maybe drop you some links on that, because I do have the receipts. That's what those guys are saying, because they want the sensationalism of putting those types of articles out.
I always take the trough of disillusion with a pinch of salt.
Yeah.
But I think what it's showing is that it will go through a period of assessment, because I think a lot of the processes, there'll be low-hanging fruit processes that you can, give to a Gen AI and say, get on with it fairly rapidly. The others where you've actually probably got to completely rework the whole business flow that you're trying to automate.
Yeah, exactly.
Using AI, and that will take time.
I'm just going to say that, and that was going to take a long time to do.
That was going to take a long time to come. So, but in that long time, there is a risk to some of the companies who've jumped in from a construction point of view, and I would say, CoreWeave's was an interesting one, but I think there are others who've borrowed heavily to get into the space, which may play into the hands of the big hyperscalers who've got big, deep pockets. And I think that's the issue, is that you'll need big, deep pockets over the next 10 years in order to provide the capacity for all the AI applications that we expect to see happen.
Exactly. Yeah. Okay. So, so the 4 points I think that they had to consider was, they said the AI value chain, so customer-driven view, of infrastructure utilization to kind of look at that. How you can maximize value. Look at how you can maximize value from existing capex. What are the durable business models and investment opportunities? And then the fourth one was identify any potential risk as you kind of go along. And those were the kind of the concluding points. So I think the point that I mainly, like I said, picked up on and I liked was the fact that it's not a linear growth. It's going to be an ebb and flow sort of approach. That was what the senior guy said, and I like that point. But that was kind of the main thing I picked up on. A lot of the rest of it was kind of academic. We need lots of data centers. Yeah. We need lots of power. Yes. SMRs are too far away. True. So a lot of that was kind of stuff that we already knew.
I think, well, yeah, there was some when you unpack it, there was some interesting stuff because they were saying the supply chain issues. If you want new transformers, it's a 4-year lead time. If the rare earths that you're after, for a lot of these things, could cause problems.
And even at the Cloud Expo Europe, that was mentioned when we were at the
absolutely.
So
there are long
data center. Yeah.
There are supply chain issues. Never mind the sort of potential disruption of global events at the moment.
Yes.
There are wider supply chain issues in terms of getting hold of the materials you need. So that a lot of the thinking is, and the other thing that they did highlight was, they talked about DeepSeek, was the way in which innovation coming, and the difference between ChatGPT 2 and 3 was I think I remember it was 85% drop in compute time.
Yes.
Or compute resource.
Compute resource, yeah.
Compute resource.
Yeah.
And so a lot of the gap will be made up of innovation as we go along. So one of the things we don't know about is how quickly new innovations will make it far more effective to use. So in some senses, you can, everybody's sort of blowing the whistle and saying we haven't got enough power, we're never going to, and it's, when you think about trying to upgrade the grid, how long it's going to take, and the small reactors will take, as you say, at least a decade and probably longer to get into commercial use.
Yeah.
Actually, it may be innovation that saves the day rather than new power.
Exactly, and that's, I think what's the likes of these sort of DeepSeek models and so on has said, or has shown, is that we can actually do things in a lot more efficient way, right? Yeah. And I think this will maybe go back to that ebb and flow that they mentioned. I think that kind of makes sense, and that we will get to a stage where we need something, and then we say, actually, we can do this a lot more efficiently, so we need less of those kinds of resources and whatever, and then we come to the next sort of paradigm, and then we go, actually, we need more of it again, and so on. So it's going to be,
and they talked about off-grid as well. I mean, they were talking about fuel cells and the like, and I know that the hyperscalers have been looking at off-grid capabilities.
Yeah.
And obviously putting data centers where power exists today and isn't used. So in old industrial sites, etc., which is we see, and that is happening. So.
Indeed. Okay, so I think we've exhausted all of that. I think before we get to blows, let's conclude this month.
Yeah, we're definitely going to have to get an agreement between us about the use of the term data center.
Yeah, that might be a future topic, guys. So we'll see. Okay, well, thank you, Paul, very much for your time. Really appreciate it as always. Really fantastic. I said at the beginning this is going to be a really good one because we had some really good topics. So yeah, I appreciate all your insights as usual. All the stuff that Paul gets up to, which he's not going to be doing for the next 2 months because he's off on holiday, putting his feet up somewhere in the sun. We'll include all of that in the description of the video, all the stuff that we talked about, links for everything's in there. As I said at the beginning, if I can't fit it all in there, because YouTube is very stingy with the amount of characters I can have in the description of the video, look out for it in the first comment. I'll have to try and pin it in the first comment or so as well. If you have any topics for us that you want us to look at in the future, please submit them. Drop them in the comment section of the videos. We'd love to actually hear about that. If you have something specific, drop the link in there as well, and I'll try and maybe pick that up and see if that's something that we can tackle in a future episode. Next month, there's going to be somebody else who's going to be my guest on Class Data Below. Paul takes a well-earned and deserved break over the next couple of months or so, maybe even longer. You never know. But hopefully, we'll have Paul back in the autumn at some point, or towards the end of the summer. But yeah, expect somebody else in Paul's chair, not physically in Paul's chair, but kind of virtually, and kind of taking over from Paul in the next couple of months. So we'll see what those guests are actually going to bring to the table. So we look forward to that. We look forward to welcoming you guys back again. Please check out some of the other videos in the other on the channel as well. Some of the other videos as well. So like I said, I do try and put out as many as I can and as regularly as I can. Please consider subscribing. Again, YouTube's still telling me that most of you are not subscribed to my channel. I would really appreciate if you can do that. That'll really help me out. That'll allow me to put out more content for you as well. As we said, drop some comments about the topics we picked up on today. What's your thoughts on those as well? Thanks everybody for watching, and we'll see you next time. Bye for now.